Hi there. Uh, so the plan for today is I'm gonna do 45 minutes, 10 minutes more or less of debugging the Lisp app, going through the flow, understanding better how the app works, then 45 minutes of Python, or 10 minutes up and down, and then 1 hour of articles and online learning. So let's start. Yesterday I didn't have my best day, not gonna lie. I didn't have my best day. I was tired. It was already late. I worked until late. So what's the name of this? Dracula. So what? Yeah. It wasn't the best of days. I didn't learn much, to be honest. But now I think I have everything here. Everything is running. So I want to debug this and understand how it works. I understand better how it works. I know how the flow behaves, but I just want to grasp it a bit better. So what I will do is, so I don't need the read. Do I need the eval? Ah, nice. So eval, where are you? Eval. Oh, wait. I don't want to use Vim. I want to use NeoVim. Well, but not this one. Not this one. This is the method. So what is this method doing? It returns a Lisp value. It evaluates taking an environment and a Lisp value as input. If it's a symbol, get, what is the get doing? Okay. If it's a symbol, we do this. Otherwise, if it's an S expression, we evaluate the S expression, then we return V. Okay. Okay, so this is the example I'm gonna use. This is the example I'm gonna use. But let me just see. I will add. What is the add doing? Okay, so it decreases the count of elements in V. It reallocates data, V cell of this size, then does this. Wait. This is what I'm gonna do. Hello. I want to follow the stack trace in C. Looking at all the methods that were triggered while, I don't know, running the app. How can I do this? Okay, I can use GDB, which is the so it's the GNU debugger. So GDB allows you to inspect a running program, view stack traces and follow function calls. Okay, I can compile it, I can run it, I can break it, I can run it. When the program pauses at a breakpoint or upon crashing, you can see the stack trace using backtrace. GDB functions. I'm gonna trigger it. Why can't I see the just a second. It's here. It's break 818. I'm gonna break here. So after all the other logic has been run. So now if I do this, no, I need to run it, sorry. I need to run the GDB, start this, then I can run it. It's here, and if my friend ChatGPT is right, I should be able to see everything with backtrace. What? How? I don't see shit. Frame 1, frame 2, what the fuck? When the program pauses at a breakpoint or upon crashing, you can see the stack trace using maybe I should use wall grind. I think wall grind is a bit better. Functions. Now if I run the same command that I have here, okay, that's it. So I'm running main. And I'm running 816, which is here. Then I'm triggering this. Just a second. How explain this stack trace, please? Why do we have to main two sources starting from the main method? Let's see. I have no idea why. So interpreting the stack trace. The stack trace captures function calls, memory allocations, and reallocation. Volgrind reports that reallocate was called multiple times. The program experienced an issue with memory, possibly an invalid read-write to memory, but it didn't experience any problems, right? No, it didn't experience any problems. Why are you saying that? What have I done here? No, I didn't. I wanted this. Functions. Yeah, this works. But for some reason, why does it work twice? What? Def add 2. Let me just see if this has been triggered by the way I copy things. Yeah, it has been. Okay. Let's do this again. So I'm checking wall grind. I'm gonna do the same thing. Def add x epsilon plus x epsilon. Okay, same thing. Why are they? Where the fuck are you here? Why are there two identical segments? The key to understanding the repetition lies in how memory management functions like reallocate interact with the call stack. This repetition occurs because function calls leading to multiple allocations. When your program allocates or reallocates memory via reallocate, grind records all active function calls leading up to the allocation. In your code, L will pop is called multiple times during different logical paths. Okay. So what happens? So we have two stack traces. Main, eval, s expression, call, lambda, pop, reallocate. Okay. Okay. So what's the first one? Main. Then we have this guy. And then this guy will trigger evaluate s expression, and then s expression will trigger L will call, and then this will trigger built-in lambda, and this will trigger L will pop, and then we will reallocate. So let me just open. Let me just open my tablet. It's here. So I'm gonna do it here. So let's think about this. Let's think about this properly. So what do I have? And how is this working? I'm hitting main. What? Sorry, no idea what happened. I didn't have my toolbar here. So what I'm hitting at line 816. I'm just gonna reduce this a bit, so at least we can see the code on the left side. Yeah, maybe like this. So first, I'm hitting main 816. It's here. Next, I'm hitting 520, which is this S expression method. Then I'm hitting 484, which is eval again. Then I'm hitting 507. 507. Is this 507? Which is calling call. Then call is here. If it's a built-in, return a built-in. Okay. Let's debug it. Let's debug all of this. Let me just copy this. So I have it somewhere. So I have it somewhere and I don't lose it anywhere. Okay. Why is this not properly indented? Okay, I don't need to put it in code. It will work without it. .816. So what will happen here? So what will we have? We will have the main, which will trigger eval. Then we will trigger eval as expression. Next, we will trigger eval again. The S expression again. Eval call. built-in lambda, and finally I will pop. Is the other trace the same? I mean, eval s expression eval l call built-in lambda pop, and at the end reallocate. So let me trigger this. Let's see what happens. So functions. No, I want to debug it. GDB. Func. No, it's GDB. Functions like this. Break. I don't need the main, but I will need it at 500. Maybe not 500, maybe 513. I need another breakpoint. 484. 484. Maybe not here. Maybe. Sorry. 484. 483. 483. Another one. 520. I already did this. 507. I already did this. 615. Oops. 615. I'm gonna trigger it at the 614. 476. No. 476. 476, gonna trigger it at 466. 466, and I have another one. 475, 476, 189. 189, but I'm triggering it where? 185. 185. And then reallocate. I think this is okay. Yeah, I think this is okay. So run. No. So let's debug this pretty simple method, but which under the hood is quite more complex. X epsilon plus x. Okay. I think I made a mistake setting up the breakpoints. Did I? 5. No, I think I didn't. Pop. Actually, I did. I should have been doing this at 192, but okay. So. What are, oops, I just forgot. I have my tablet all over this. What are the most used GDB commands? I think I asked the question yesterday. Break. Wait, let me delete this. I don't need this. So list all breakpoints. If I type info break, 185. How can I delete this? Delete 5. Okay. Continue. Where are we now? We are at 513. If I'm correct, 513 is the level eval. 513. Yes. So. Just a second, please. Just a second. So it's def add the lambda x epsilon s arguments and plus x epsilon. So it's here. So print v. V is a Lisp value. Print v type. What's the type? It's 4. It's 4. 0, 1, 2, 3, 4. It's a Q expression. Here. So we have a Q expression. So print v count 3. Print v cell 1 type. So what's this? 0, 1, 2, 3, 4. So this is an X expression. So what's the first one? It's a symbol. So print v cell 0 symbol. It's def. What's the third one? Why can't I access? It has how many? It has 2 children. So this is the 2 type. It's 4. So where is the method that we called? So the first element is a symbol. The second element, it's a Q expression. It's this one, I assume, and I think it is. Print v cell 1 type 5 count 1 cell 0. So what's the first element? It's 2. It's a symbol. So if I print sim, what will it print out if I print out sim? What will it print out if I print out sim? Is it add? It's add. It's add. Just a second, let me get a glass of water. I'll be immediately back. As I said, I'm back. So it's add. So the first element. How can I think about this? So V has three elements, and the type of it is it's a Q expression. So a Q expression consisting of 3 elements, right? V type, it's a Q expression. So what will happen now? If we have, what line am I? I'm 513, so I'm here. I'm checking it if the type is a symbol. It's not. So I can go next. If it's a next expression, which is not, I can go next. And I'm gonna return it here. 3. How is it? Wait. 50, 0, 1, 2, 3, 4, 5. It's not a nice expression, right? Print v type. Print v type lol. How is this a nice expression? 4. 0, 1, 2, 3, 4. Okay. 0, 1, 2, 3. I have written them for my tablet. I have written them wrong way around. So I need to just clean this. Or I can do this like this. I'm gonna select all of these. And I'm gonna select this, move it up. What color is this? This red. Yeah. Okay. So now I cleared the confusion. So it is a nice expression. So what will happen is, where am I? I'm 520. 520. I'm hitting lol s expression. Lol evil s expression. Where is it? It's here. So now let me skip into it. I'm now at 483. Yeah, I'm here. Okay, if you have just joined, if you are watching this, basically what we are doing is I'm trying to debug the app I've been written. I'm trying to debug it to try to understand it better, so that's why I have all of this running. So where are we? We are here at line 483. So if I'm gonna print out v count, it's 3. So if I go next, print v cell I, so print I0, print v cell 0. What's the type of this? The type of this is 2. 0, 1, 2, it's a symbol. Print v cell. So basically, how do I know that this is a symbol? Because this is an enum value. The type is an enum, and I have my enum written here. I'm just gonna open my tablet again. So this is my list of enums, and I know 0, 1, 2. It's symbol. That's how I know that this symbol. I also have it written here in the app. Here. So basically, I'm just enumerating. I'm enumerating the types of the Lisp values. What have I done? Have I written something? 5, 2, 4, 8. So what's the value of this symbol? It's def. So what's gonna happen now is we're gonna try to evaluate the def. So if I go to evaluate and here, so if I'm gonna go next, okay, so we trigger now the level eval again. If we go next, we are hitting the environment get method. So if I go in this method, it's here. So this is the method that I'm right now in. No, I wanted to skip here. Fuck. But basically what would happen here is I would iterate through the list of environment and I would try to find the symbol that would be equal to whatever symbol we have here, and the symbol that we have here is def. So I would probably, let me just use continue. Let's see where print v type, it's 5. So now this is a less expression, v cell 0. No, sorry, print v count, print v cell 0. What's the type? It's a symbol. What is the symbol value? It's add. Okay, let's do the same thing. Let's do the same thing. So next, S expression. Is it an S expression? No, it's not. Next, I'm returning it. And where am I going further? Here. V type print v print I. So it's 1. Print v cell. The first cell type, it's 5. So 483. So what are you doing now? You are iterating through all of these and then you are evaluating them. You are evaluating them again. But considering that the first one is just the first element was a built-in method, which was masqueraded as a def keyword. The second one is a Q expression, and the third one, we sell to, what's the type of this? It's 4. Print we sell to, it's 4. So what's 4? It's a NES expression. Count, it has 2 elements. Cell 0, what is the type of this? No, let me follow this. So what will happen here is I'll go next. So I'm hitting the eval. I can step into it, considering that this element is not a symbol. We're gonna skip this. Consider that the element is not an S expression. It's gonna skip it. So it's gonna return it. Oops. 520. Where are you? 520. Ah, you are here. It's 4. So now I can skip into it. Now I will print count. It has 3 elements. So what's the first element? The first element is a symbol. What's the second element? Type. It's a NES expression. Okay. Where am I? Where am I in the code? I'm here. 483. So 483. What will happen now? Next, I'm evaluating this. So next. Next, 483. Is there a skip? No, I have continue. What finish? Continue. So I have another breakpoint. So this is gonna be an X, yeah. And the second one is gonna be an epsilon. Okay, so where are we now? 513. I'm here. So next, it is a symbol. No. Print v type. Okay, continue. Print v type. It's 5. Continue. So I'm here now at 614. It's a function. It's a built-in lambda function. If I go next, it's gonna return the built-in 615. It's gonna return where is 615? It's here, so it's gonna return the built-in. A built-in consisting of two elements, and I assume that the first one type is a co-expression. So this is gonna be X. This is gonna be epsilon. Oh, sorry. This is gonna be epsilon. I assume the second element. So 615. But where did it build this function? That's what I'm interested in. Where does it build it? Because I'm here. I'm here. Where do you build this guy? Okay, for those of you, oh, I had a lot of viewers at one point. I don't have them anymore. But if anyone is watching, what I'm trying to do, what I'm trying to understand is, let me just show you. Maybe this is gonna be the best way. I have this structure, which is a way to define functions in our Lisp-like language. So I want to see how did we actually create a Lisp function, a Lisp type of function by providing all of these special keywords. That's my point. Let me just turn this off. Okay, I'm trying to understand how this works, and I'm trying to understand how this works, but it doesn't fit in my head. I want to know how the built-in is created. That's what I want to know. So if I call, where's the next instance? It's here. Ah, so it's here. Here we actually where are my constructors? I want to see where the constructors are being called. Lol fun. Add built-in. Okay. So it's most probably done here somewhere. But still, how do I print a type? So what's A? So A is a function. 614. 614. 614. Okay. So if anyone is watching this, what I'm doing is I'm trying to debug. I'm trying to understand why and how this structure, which I wrote as an input. Where's my pen? Here. How this gets transpiled or converted into a function. As you see, this is the input, and as you see here, we are in the method. Where are you? Lval call here, and it treats my Lisp value as a built-in method. So, which I assume is this. Is it lambda or def? I think it's def. Wait, let me just check. Built-in lambda. No, sorry. Let me just check it. Where are the constructors? They are here. Okay, so it's not a lambda, it's a function. It's a predefined function that we have in our application. So 615. Return the built-in. Okay, what if I do continue? Built-in lambda 467. No, 467. Where are you? You are here. Built-in lambda. So what do I have here? I have a. It's a function. It's a function. And the function has the following structure. It has a built-in method. It has, oh god, it has the Lisp environment, right? It has the formals and it has the body. Okay. What are my formals? Formal for another Lisp value. So print a formals count. Why can't I access it? Why can't I access this? Have I created them even? Seven one. I still haven't created them. Wait. Print a count. I have. Okay, my mic was off for a moment there. So I have two elements here. So the first one, well, 0. The first one is a Q expression. So it most probably is just the list of my arguments. So if I do this, if I check the first element so this is my Lisp value. My Lisp value is a function. Now my function consists of two elements, as you can see here. So because my Lisp value consists of two functions, right? So you have two elements. I assume that the first element is the list of arguments, which I'm gonna test like this. If the symbol is sex, yeah, definitely. Now the second thing, the second cell, I think it's another, yeah, it's another S expression. And now this one, cell 0. The second one, how many elements does it have? 0. So the second one is a symbol. It only consists of plus. And it only consists of plus. How does this even work? Print a cell. The first element, cell. The second element. Type. Okay. Hi, for everyone for anyone who's watching this, I'm trying to debug. I'm trying to debug a command that I added in here. Let me just show you. So this is the way we define functions in this Lisp-like language I created. So what I'm trying to do is to understand how this gets converted into a function in Lisp, in this version of Lisp-like language. So currently I arrived here. I arrived inside a built-in lambda, which creates and builds a built-in method. And basically here is where the magic happens, because here we are popping the formals, which are the arguments of the method, right here. And after that, we are popping the body. So actually, I can do this. Where am I? Next. 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 I think this is okay. It's triggering again. Next. Okay. Next. Now formals. No. Print formals. Print formals cell 0 symbol. It's X. Yeah. And what X is this? It's the X. Let me just also print out the first element and the epsilon. So those are these two elements. These are the arguments from here. Now let me see the body. Next. Oh, I'm just going to turn this off. Next. Print body. print body count, it's 3. It's 3. It's 3. So if I do print body, the first element, and the type, it's a symbol. If I do the symbol, it's a plus. The first element is X, and the second element will be epsilon. Okay. Okay. So I have the body as well. This is, I have both the body and both the body and the formals. So now if I do continue, 614, 614, print f. Is it 4? It's 3. Print, so what's 3? 0, 1, 2. It's a function. It's a formal function. So if I go next, and if I go skip into it, so I'm returning the def. So if I go next, if I go continue, that's it. Okay, I think I understood how this works. I still have holes in my understanding, but I think I have a good grasp of it now. I think I'm ready to start the next chapter next time. Okay. Okay. Now, I wanted to do something else. I wanted to do something else. I think I'm good with this. Now, how does this work? Do I need it like this? Okay. I'm good. I'm good. I'm doing well. I think we will continue in the next episode. I think I have a good grasp of it. And in the next episode, I think we are starting conditionals. So see you in the next one regarding C. But now I want to do something else. And that's something else.